Hello. So I'm going to go over the exercise over DNA replication. Let's get ready to replicate using the 3D Molecular Designs DNA Replication Kit. And so you'll be using the DNA replication mat, sequence 1 and 2 for replication and transcription, the DNA pieces, the RNA pieces, and the DNA polymerase pieces. So the first thing you'll do is assign a sequence to students. I'll be going through sequence 1, and as you can see, it shows the DNA molecule with both strands and the sequence for both strands, and they'll use this as a template to make their DNA with the DNA pieces, like so. And they will use the DNA replication mat per the instructions to feed the DNA into helicase, which will separate the strands. They will need to separate the strands so that they have about 15 free DNA pieces for each strand. All right, so once that is done, they will be able to identify which strand the leading and the lagging strands will be based off of. The mat also shows our ends. So this will be the 3' end for that strand. And over here, this will be the 5' end for this strand. And we'll start first with our leading strand. So the leading strand will be built towards the replication fork. So we're going to have a primer synthesized by primase that will add RNA nucleotides. As you can tell, these nucleotides are different from the DNA because they have a square shape here. And so students can model primase, adding those RNA nucleotides in a 3' to 5' direction. And then RNA primase, and we can use our piece here. We'll add the DNA pieces in a 5' to 3' direction. And now we need to do the lagging strand. So if we count 10 spaces down from this end, primase will synthesize a primer for the lagging strand. And then our DNA polymerase will come in and synthesize the strand using the DNA nucleotides. Now we are going to open up our DNA double-stranded molecule another 15 spaces. And we will keep going on the leading strand here. Next, the lagging strand. And again, we count 10 spaces down, and Primase will add another primer to the lagging strand. And then DNA polymerase will come in and add DNA nucleotides in the correct direction. Now, when we get to the next segment, when students add the last nucleotide, they'll want to not connect to the next segment because ligase is the enzyme that will come in and connect those at the very end. And we're going to continue separating for about 15 DNA nucleotide pieces by helicase, elongating the leading strand and adding the lagging strand. Primers and then elongating those, but not connecting the segments. And so by the end, we have our 2 glorious DNA molecules. If you'll notice, we had a primer for adenine that, since we don't have thymine, was a uracil RNA. And so be sure and warn your students about that. And so DNA polymerase 1 is now going to come and replace those RNA primers. And the students can model this as well, that the DNA polymerase 1 removes the primers and then replaces those in a 5' to 3' direction. And for the lagging strand as well. Now remember, we still have the unconnected fragments, the Ozaki fragments, that ligase will still have to come in, connect for our last step. And after the students have replaced all the primers, then they can go into the lagging strand and model ligase, connecting the fragments using phosphodiester bonds. And at the end, we have 2 lovely identical DNA molecules.